Hello, this is Mrs. Decker, and this lesson is on Objective 2B, Predicting Products. So in this lesson, you're going to learn to predict the products for a synthesis and a combustion reaction based on the provided reactants. Before we jump into Lesson 2B, I want to do a quick review of Lesson 2A, labeling the types of reactions. So go ahead and pause this video for a minute and label the 5 types of reactions below. All right, number 1 is a double replacement reaction. Number 2 is a decomposition reaction. Number 3 is a combustion reaction. Number 4 is a single replacement reaction. And number 5 is a synthesis reaction. In our last lesson, we learned about what a combustion reaction is. It's an element or a compound rapidly combines with oxygen to form an oxide and water, and as a result, we get heat or thermal energy released. So here is our generic equation. We have our hydrocarbon plus oxygen, and that gives us carbon dioxide and water. So the generic equation is not all that different from a specific equation. Now we have a specific hydrocarbon that combines with oxygen, and we get carbon dioxide and water. So for your example problems, these are what your problems will look like. So your first step is to identify that these are combustion reactions. So we see our hydrocarbon and oxygen, so that tells us that that's a combustion reaction. We know that the products for all combustion reactions are carbon dioxide and water. So once you've labeled it as a combustion reaction, you can go ahead and write your products as carbon dioxide and water. Okay. So now that we've predicted the products, the last thing that we need to do is balance the equation. So to balance the equation, remember you want to draw a line down underneath the arrow and draw the types of elements that you have on each side of the line. So on the reactant side, we have 1 carbon, 4 hydrogens, and 2 oxygens. On the product side, we have 1 carbon, 2 hydrogens, and 3 oxygens. So our carbons are already in balance, so we want to start with either our oxygens or our hydrogens. On the product side, we have an uneven number of oxygens, and we can only have an even number of oxygens because of the O2 in the reactant side. So we want to start by adding a 2 here to try and even out those oxygens. So that gives us 4 hydrogens, and that changes our oxygens now to 4 as well. Okay. So now carbons match, hydrogens match, we just need to fix our oxygens. If we put a 2 in front of the O2 there, that gives us 4 oxygens, and then that equation is balanced. Now for example number 2, this is also a combustion reaction, and we can tell by the hydrocarbon plus oxygen. So we know our products are going to be carbon dioxide and water. Okay, the hardest part of the combustion reactions is balancing them because they do tend to be a little bit more challenging. Okay? So you want to balance this equation. So you need a 2 there, a 6 here, 4 in front of the CO2, and that gives you 14 total oxygens on your product side. So you will need a 7 in front of the O2. The second type of reaction that you need to predict the products for are synthesis reactions. So let's review a synthesis reaction. When 2 or more reactants combine to form a single product, that is a synthesis reaction. So our generic equation is A plus B equals AB, and then our specific equation is magnesium burned with oxygen turns into magnesium oxide. So before we can predict the products of a synthesis reaction, we need to do a quick review of a previous lesson. So all of the elements in group 1A have 1 valence electron. They're going to lose that 1 valence electron, and once they do that, their charge will be +1. 2A has 2 valence electrons, so all elements in 2A will have a charge of +2. 3A will have a charge of +3. Remember, we skip over 4A. 5A has 5 valence electrons, so they will gain 3 electrons, so the charge will be -3. 6A has 6 valence electrons, they will gain 2, so their charge will be -2. And 7A has 7 valence electrons, so they will gain 1, so their charge will be -1. So when predicting the products for a synthesis reaction, you will be taking the single elements in the reactants and putting them together to form a compound. The trick to forming those compounds is to make sure that the formula is neutral. So sodium will have a charge of +1, chlorine will have a charge of -1. So +1, -1 balance out. It will be a neutral compound if it is NaCl. Calcium has a charge of +2, fluorine has a charge of -1. So you'll need 2 fluorines to balance out the +2 charge on calcium. So your formula will be CaF2. Lithium has a charge of +1, oxygen has a charge of -2. So now you need 2 lithiums to balance out the -2 charge on oxygen. So your formula will be Li2O. Okay. Aluminum has a charge of +3, oxygen has a charge of -2. So to make this a little bit easier to figure out, you can write them next to each other. Aluminum has +3, oxygen has -2. So you just want to cross the numbers and drop the charges when you write the formula. So you should get Al2O3. All right, so here are our example problems for synthesis. So our first example has sodium plus iodine. So when you're creating the formula, you want to ignore this 2 for right now. So you write sodium and iodine. Sodium has a charge of +1, iodine has a charge of -1. So you only need 1 sodium and 1 iodine to make a neutral compound. So your formula is just NaI. So now your last step is to balance the equation. We have 2 iodines in the reactants, so we need to have 2 iodines in the products. So put a 2 there. Okay. So now iodines are balanced. You just need to balance out the sodiums by putting a 2 right there. Example problem number 2. Again, we're going to ignore this 2, and you're going to put the 2 reactants together. So barium and chlorine. Barium has a charge of +2. Chlorine has a charge of -1. So your formula is going to be BaCl2. Now that our formula is complete, we want to balance the equation. On the reactant side, we have 1 barium. On the product side, we have 1 barium. On the reactant side, we have 2 chlorines. On the product side, we have 2 chlorines. So this equation is already balanced. So that is how you predict the products of combustion and synthesis equations. There is practice in your packet for you to work on. Let me know if you need help.